Welcome to EDU World Space.
Question number 63 wants us to determine how far apart the eyepiece and the main mirror in a reflecting telescope should be in order to have the image of an object being viewed at infinity. This problem is illustrated to us with the figure in figure 34.63, which I've recreated here. What it shows us is the light traveling through and hitting the spherical mirror at one end of our reflecting telescope, and then being focused onto an eyepiece, which is then being viewed by the human eye. Now, the distance between the objective, or the image being viewed, in the telescope is equal to the sum of the two focal lengths in the telescope. Inside the telescope, we have two objects that are working to focus light. One is the main mirror in the telescope, and the other is the eyepiece. We're going to call the focal length of the main mirror f1, right here. And then the value, the term for the focal length of the eyepiece will be f2. So all we need to do to find the distance between the eyepiece and the main mirror is just to add these two focal lengths together. So add f1 and f2. We're given a couple values in our problem. We're given the radius of curvature of the main mirror. It's 1.3 meters. And actually, we are given the focal length of the eyepiece. That has a value of 1.1 centimeters. So all we have to do to solve this is figure out what the main mirror's focal length is. To find f sub 1, all we need to do is take that radius of curvature for the mirror and divide by 2. That's how we find the focal length of a spherical mirror. All we need to do is take 1.3 meters and divide by 2. And we find that the main mirror's focal length is equal to 0.65 meters. What this means is that our value for d will be equal to 0.65 meters plus that 1.1 centimeters, which we're going to have to convert into meters. Just dividing by 100 gives us 0.011 meters. Finally, the sum of those two figures gives us a value of 0.661 meters for the distance between the eyepiece and the mirror in that telescope. That's about 66.1 centimeters. Now, the second part of our question wants us to determine the angular magnification for this telescope. The way we determine the angular magnification m is to take these two focal lengths and divide them. Now, there's a negative sign out front of our division here. That's because the image will be inverted once it reaches our eyes. So what we'll be doing to find the magnification is take the focal length of our mirror, f sub 1, and divide by the focal length of the eyepiece. So what we'll get is 0.65 meters over 0.011 meters. That gives us a value of 59.1 for this telescope's magnification power.